Alright, hi, what's up? Satellites. No kidding, lots of them. But check this out first. I've got slate pencils, not just one, but an entire box of them. So I'm never gonna run out of these again, unless I decide to eat them or something, which I won't, hopefully. Right, back to topic. So ISRO has finished launching their constellation of 7 satellites in 2018, and these satellites are orbiting with the Indian landmass ever since. So I'm saying with the Indian landmass because 3 of them are geostationary and the rest 4 are geosynchronous. So they're always overhead if you're in India, or I should say that their angular velocity is matched with the angular velocity of the Earth. And here is the Indian landmass, and I can hear your minds go like, I hardly think that is the Indian landmass, but it is what you get in this video, and I've tried my best to sketch it from the point of view of a Martian under a minute. So do not complain. Alright, so this constellation is providing navigational, positioning, accurate timing, and other services which come along with satellite navigation systems like GPS, GLONASS, Galileo. There are others, but I just named the American, the Russian, and the European satellite navigation systems. And adding to that list, India has added their own satellite navigation system called NavIC, navigation using Indian constellation, or the entire system is also called IRNSS, Indian Regional Navigation Satellite System. And as of 2020, they have this system has 7 functioning satellites, providing a resolution of 10 meters within the Indian border and 20 meters outside. Yes, it can be accessed outside the Indian border also, and to be very specific, we can access it up to 1,500 kilometers outside the border. It is roughly like that. It's not exactly 1,500 kilometers, but it depends on the latitudes and longitudes and how the borders are how the borders are shaped. So right, so as electronics designers in 2020, we do not have to rely on only the GPS receivers, which can receive foreign navigation systems like GPS, GLONASS, and Galileo, which this receiver can. This is in the form factor of a Raspberry Pi hat, and it features a Neo 6M module, which is a GPS receiver which can receive Galileo, GLONASS, and certain other, I think certain other constellations also, but I'm not sure. I have to check their data sheet. So anyway, so we can, as Indian engineers, we can move away from these foreign receivers, and we can use these, which I got yesterday morning. These are manufactured by Skytraq with a Q, and the part number is S1216F8-GI3. There's also a GI2 version, but as far as I can remember, the GI2 has a poorer receive sensitivity, so it would matter if you are receiving the NavIC signals from the ground floor of a tall building, or if something large is over your head. So this would perform better, and this to state the metrics, this has a receiving sensitivity of minus 160 dBm. But in this video, I would not go into all the details and the dBm values and everything. So yeah, we can buy these in India. Also outside India, we can buy these. And when designing a navigation system or designing a circuit board with positioning and navigation ICs like GPS receivers and stuff, we can really give these a thought and in fact keep these modules in our arsenal when designing those things. So this video was really to make these NavIC receivers and the entire IRNSS system popular within India, because still even after 2 years of this system being online, we are not using it in our designs. So that is a shame, and I am guilty of it myself. So yeah, we can really move away from the GPS receivers and which are receiving foreign navigation systems, and give our own indigenous system a try. And in fact, Qualcomm is working with ISRO to integrate NavIC systems into their into their chipsets, which are going to be rolled out in Indian smartphones. So once that happens, this system will really gain some good traction within India and outside in our neighboring countries as well. These are not only receiving NavIC signals; these are also receiving GPS signals in the L1 band and the GLONASS signals. And since we are talking about the bands, I should say that NavIC is using the L5 band for civilian use, and I'm not really sure for the restricted military use what they're using. And there are a whole host of other features which are available to the military, to the Air Force, to the Navy, and of course not to the civilian. There are a lot of encryption going on in that restricted services, in those restricted services. So the civilian band is the L5 band. This receiver which I showed you from Skytraq is receiving NavIC signals in the L5 band, and the specific frequency, as far as I can remember, is 1176 megahertz in the L5 band. So if you need an antenna with that receiver, and of course you will, the antenna should be matched to somewhere around 1176 megahertz. And also I have compared the footprint of this module with the U-Blox 6M or the 7M. All of those have similar footprints. So I've compared the footprints, and it seems that the footprints are very similar. And in fact, I can tell you that these footprints are exactly similar. Skytraq has borrowed this the very popular footprint of Neo 6M, and placed it or used it in their Skytraq S1216 module. And that is a good way to go about designing a module if you had to make something popular among designers, because designers already have open source boards or self-made designs which are built around this Neo 6 module, which is a very popular GPS module. And in India, if the pin mappings are same, which I really hope are, and I'm talking about, by pin mappings I mean the pinouts, the groupings, and which pin has which function, that is called the pin mapping or pinout. If the pin mapping is the same in these two modules, then these two modules are basically replaceable, or you could swap this module with this module in India and in indigenous systems, and you could receive NavIC signals. This one obviously cannot receive NavIC signals, but this can receive GPS, GLONASS, and Galileo and other navigation satellite systems. So yeah, I really hope that these two have the same pinouts. I haven't checked, and I haven't done any extensive testing with this. I mean, there was an idea among electronics engineers that yes, ISRO is launching a system, but how do we incorporate them in our designs? We cannot. And ISRO has not done sufficient marketing or awareness spreading that yes, you can design your own systems using the NavIC receivers. There are NavIC receivers which have footprint which you can hand solder, and yes, you can hand solder this if you have a little bit of experience with hand soldering. But yeah, of course there are ICs also which are BGA packages which you cannot hand solder, and ISRO are using those packages for their own ground stations and everything. So yeah, this was just to make this system popular, and I encourage you to buy these instead of the GPS receivers. And in fact, these can also receive GPS signals, so you would not lose anything if you buy these. So if you're wondering about how much it would cost to buy you one of these, I would first recommend you against buying it from IndiaMart, because there are IndiaMart sellers which are who are trying to scam you, who are just hell-bent on making 100% profit on these little modules. And I have asked for a quote from 3 or 4 of them, and all of them were like 4,000 or 3,500 for 2 modules, but that is not the actual price. So there's a seller in Bangalore. They have a website. They're called Fides Electronics. This video is not at all sponsored by them. They do not even know that I'm stating their name in this video, but they shipped these 2 modules within 2 days, and they have an excellent customer service. At least I feel that their customer service was excellent. So this company is really nice, and all I had to pay for 2 modules was 1,810. That is much cheaper than all the IndiaMart sellers. Right, yeah. All the IndiaMart sellers were asking like 4,000 or 3,500, and the price per each module from Fides is 703. So I would not pay anything more than 1,000 for these modules, and I think 703 is a good price for these things. And as these become popular, if the supply isn't increased much, if these become popular, the price will increase. So as far as I can tell, as far as I can suggest, if you had to stock up on navigational units, navigational receivers, satellite navigation receivers, you could really buy these now, because the prices are good for these things. It might skyrocket or something. Yeah, I don't know. It might also reduce if Skytraq rolls out a lot of these modules and the demand does not increase that much. So yeah, this would be a good time to buy these modules. So yeah, as I mentioned, this video was really to make this system popular, and in India especially, we should use these modules instead of the GPS ones. At least we should try and compare them with the GPS modules. So yeah, after I have done some testing for these modules, I will probably make another video to document the test results and everything. So I think I'm going to sign out for this video. I'm going to end this video. So goodbye.